Yeah, we live. I hope I remember how to do everything here. It's been a while. I hope I remember how to teach maths, all kind of thing. Relations, functions, and graphs is the next topic in all of the multiple choice series that we are doing. The relationship in the diagram is best described as this side. No. Oh, geez, and ages. I have a little problem here. So I was wondering if I remember how to do the thing. My tablet attacking the wrong screen right now. All right, so in the meanwhile, what you all could do is let everybody know we live. Just know, let's fix this problem real fast. Don't worry yourself. This one? Is it this one? Yes, this one. Think we should be in the game there. How things? How these studies coming along? Y'all could press like on the video. Let's get this on the road. The relationship in the diagram is best described as, right, we will kill it. It's best described as, well, there's a split right here, so you'll see not, okay, this is 1-to-1. And if there's a split on this side, that's 1 to many. If there's a split on this side, that's many to 1. So this is many to 1, because you've seen splits on this side, that's many to 1. Many to 1. So the answer is C. How many of you all knew that? You know that? You know that? Many to 1. Press like on the video, y'all can share it on Instagram and thing and let people know we live out here. There's no split on this side. If there are splits on both sides, that would be many to many. Which of the diagrams below best illustrates a function? Well, a function cannot split on the input. You can't send, imagine this is a factory called a function, and you're sending something. You can't send in something here in a function and it's split into two. That functions don't split things into two. You know, how to say this? You could send in something and send in something completely different and end up with the same thing. So you can have this split on the side with the output, but it can't split the input. So you can have many to 1 things that are functions, like a quadratic. Quadratic is a function that can be many to 1. Yeah, Javish. But so all of these with these splits here, those are not functions. So the best answer is actually D. In this case, D is a function. The function f of x multiplies the sum of the variable x and 3 by 2. And is plus. So it multiplies the sum of the variable x and 3 by 2. What is the inverse of the function? Oh, I find an unseen answer, I get a little worried. So this is f of x. So the last thing it did was multiply by 2. So the first thing you need to do is divide by 2. All right, now let's do the whole thing. Y is equal to 2x plus 6. This looking good enough. I find this one looking good on the B. Bring it, interchange variables. Y'all remember this making sense to y'all? Bring across, make x make the new y the subject of the formula. So this is f inverse of x. The answer is actually B. B in this case. All right, watch this one. I find this one was a little tricky. Watch this one earlier, and I didn't see people shoot out answers. So let's shoot out the D for the last one, but not for this one. So let's try number 4 and 5. If f of x is equal to x cubed minus 5, then f of negative 3. Just want to take the negative 3 and send it inside there. So you want to say f is equal to negative 3. This is from the last question. Negative 3 cubed minus 5. So 3 by 3 is 9 by 3 is 27. And since it's negative, you'll actually keep the negative in this situation. So you get negative 27 minus 5, which is like negative 32 or so. Yes, sir. Four ordered pairs for f of x are negative 3, 1, 2, 6, 9, 13, 11, 15. All right, so these are the ordered pairs here, 1, 2, 3, 4. If f of x is equal to y, then y, what seems to be happening here? This is 4 more. This is 4 more. Yeah, man. first try again. So it's 4 more. It's adding 4 to x. So y is equal to x plus 4. So A is the way to go. A is the way to go. Niceness. Why is in the chat if you're understanding everything so far? Yes, so this has a little bit of transposing in it, Vanessa. So which of the following represents the graph of a function? We're back at this. So they're bound to, have to, must ask you something on whether it is a function in the exam. And I'm going through all the different style of question that can happen, right? So this is a function for sure. This is not a function because you see, anytime you have vertical lines on a graph, it could never be a function if there's a vertical line. Because that carries the idea of one input giving you several, well, unlimited outputs, that is. So vertical lines and functions. Right? This can be a function, this can be a function, this can be a function. There's actually something called the, let me just pin this comment for people who just touched on. There's actually something called the vertical line test. That's the name they call it for maths, the vertical line test. So if you bring a vertical line and it manages to touch more than one point at the same time, that can be a function. So all of these will fail the vertical line test because a vertical line would actually, touch more there. So the answer is A, and obviously A is a function like y is equal to, let me say y is equal to 2x minus 3 or some kind of thing like that. The line AB cuts the y-axis at the point right here, and that point is 0 on the x and negative 1 on the y. So who is that? That's B. That one was free marks, right? Free marks. So we're going up to about 20-something questions today. The equation of the line, and we are number 8, the equation of the line which passes through the point 0.5 and has a gradient of 4 is, now it's passing 3.05. So what I tell you, this is similar to this just now. So if it's 0, that means this point is actually on the, you seeing it? This point has to be on the y-axis. That's the point there, 0.5. And the gradient is 4. So the gradient is increasing 4 units up for every 1 unit across. So this has to be this line. This is in the form y is equal to mx plus c, where m is the gradient and c is the y-intercept, which corresponds to the 5. Nice. So some of you would have gone and put it in the equation of the line and stuff and work it out that way. That's okay, but there's a fast way to do it. The range of f of x is x cubed. So we want to cube up all of these things. This is the domain, and we want the corresponding range of values. So when you cube -2, you actually get -8. So they must give you something to see if you know to cube negative numbers. Here we have our domain, our range, our corresponding range, and this corresponds to none other than B. So good afternoon, everybody. We have 132 people here, so you all can just press like on the video so we can spread it. Which of the following pairs of lines are parallel? Number 10, what are you feeling? Which of the following pair of lines are parallel? Let's see if I can just eyeball it here. It's looking like B. Because you need to get to the form y is equal to mx plus c. Sometimes c might be 0. So this has a 4 here, so I'll have to divide by 4, so I'll end up with a quarter. I'll end up with like divided by 4 on this side as well, so I'll end up with a quarter here. So the gradient here will be -4, and this one will be a quarter. So that's not parallel. Parallel lines have equal gradient. If you can't see clearly, you need to raise the resolution on your end. I feel coming down to exam, I may begin to use another streaming software because this one naturally causes people to see it blurry. But it's still on your end. You need to just raise the setting. And this is 3 and this is -3, so this is not parallel. This is 2 and this is a half. Not parallel, not even perpendicular. If it was perpendicular, it will be -1/2. So if I bring across this 2 now, it will be divided by 2. So this will be like 1/2. So a half and a half. Gradients are the same. This will also divide by 2, but we're not concerned about that. So in other words, this is the goal. That is the goal. Those lines will be parallel. Which are the following pair of lines Which of the following pair of lines are perpendicular? This is same as before. This is same as before. It has to be A. Has to be A because when I brought this one across, remember, I turned into a quarter. And perpendicular lines, the gradients are related in this format. One is the negative reciprocal, that's the word we use, the negative reciprocal of the other. So like if one is 4, the next one will be 1 over 4 negative 1 over 4. If one is like 2/3, the next one would be 3 over 2. Well, switch the sign, negative. If one is like, I'll get the point. If one is like, let's say one is like negative 1/7, the next one will be 7. Switch the sign. Next Math Live, I believe I should be live on Tuesday as well. Yes, this Tuesday as well. Last week I was in Tobago, boy, and it just wasn't cooperating. The gradient of a vertical line. So the gradient of a horizontal line is 0. The gradient of a line exactly 45 degrees is 1. What else? The gradient of a vertical line, we can't get that because you'll have to divide by 0. That has division by 0 involved in it. Because yes, you're going about a certain amount, a limited amount actually, but you're never going across. So the best answer is undefined when you see this situation. The gradient of a vertical line is undefined. Which of the following group of linear inequations best indicate the programming for the shaded region below? So this line touches at 5 and touches at 5. So this is the line. This is the line. X plus y is equal to 5. This is a shortcut how to draw these kind of lines. And you should know that from linear programming. Write down this word. Linear programming is one of the toughest topics in CSEC Maths. And go and review the videos I have on that. Yeah, go and watch them over. So if you have x plus 5, y is equal to 5, it should be x plus y is less than 5 to show the shaded region here. But you're actually seeing some more stuff, and that's correct because x is greater than 0 talks about this part of the graph where it doesn't go under the x-axis, and y is greater than 0 is suggesting that it doesn't go behind the y-axis. So it's actually trapped between these 3 lines that make up the triangle here. Yeah, so that's the shaded region here. Boom, bang, bang. Everything cool? Sure. So the graph of f of x is equal to x minus 3. This is a completed the square form. Completed the square here. This is in the form ax plus h to b squared plus k. So the minimum point is always negative h comma k. So you switch the sign on this, so it'll be 3, the minimum point or maximum point, whatever point it is this minimum? Yes, this is minimum, and negative 4. So who has that? Who has that? A. A is the way to go. Yeah. Hey, look more partner Renice, boy. Renice. If g of x is equal to x plus 2, then g. Now this don't mean g squared, eh? This is why it's knock people out. You see when they put g2 and whatever, it means this really stands for gg. All the gamers get happy when they hear gg. Gg of 3. And what this means? This means do the function, then do the function again. So for example, you're going to take this number, put it in there. So that's g of 3 is equal to 3 plus 2 is equal to 5. And then when you get this answer now, you need to put it back in there again. So now you have g of 5 is equal to 5 plus 2 is equal to 7. And that is you there. That is you there. You understand? So it doesn't mean take the 5 and square it. Or take the 3 and square it and put it in. I didn't have that answer available for you anyhow. That'd be good if they had put that answer there to trick people. So the answer is actually 7 in this case. Learn it. So these topics are actually not in depth at all. These are actually surface topics in the multiple choice. The multiple choice for CSEC is not that hard. Paper 2 is a challenge. Which of the following best describes for the average student? Best describes the variation between y and x. Well, I'm seeing that this is going down and this is going up. So I already know it's none of these. It has to be an inverse relationship. It has to be an inverse relationship. So I can substitute values to see if it works. Like y here is 1 and 8 over 8. You understand? You all understand what happened there? I'm using this one. I'm substituting the values here. Y is 1, x is 8, and it works. It's correct. And if I substitute the other values, when y is 2, they're telling me that this has to be 8 still, because this is always 8, over x is 4, which works. So B is the answer. Check it over and you'll realize that B is working for all of them. B is working for all of them. If you try any others, it wouldn't work. Yeah, man, Kyle telling me that he bought the question bank. The only question bank is available in Nigel. I can't just came off the phone talking to them, so it should be available in all of their bookstores. You could, like yourself, with the revision for CSEC Maths, go and buy it up. So we gotta supply them with some more again. Try to get it before this stock run out. What is the value of A? A? Just so? Something missing. something missing. I'll just know. I'm going to find out with number 17. Hold up. Oh, 17 is part of 16 and answer question 16 and 17. So A, look, A over here. A is over here. So when y, they want to find out what y is A. A must be equal to 8 divided by x is 2 now. So A has to be what? A is 4. A is 4. A is 4, right? So you just substitute the known value you have, the value of x, into the equation that you now confirm what the equation is, and you'll be able to get it out. Imagine so have to correct the paper and see the kind of thing we have to do. What bookstore? What bookstore? Anybody who have the book can tell me what bookstore you bought it in? Right now it's available in Nigel R. Cans. It should be available in Keith Cans, in San Fernando. A few other bookstores. You could check. You could call the bookstore before you go. All the different branches of Nigel R. Cans should have it. What inequality is shown on the number line? Well, it's trapped between -1 and 2. All of them have -1 and 2. But it's including because it's shaded. See how it's shaded? So I'm not supposed to be using these kind of inequalities. So, and it's trapped in between, so it's greater than this. Okay, it's greater than -1, whatever it is, and it's less than 2. So I want the arrows to point, I want the inequality signs to point like this. Right? You understand? So x must be greater than -1, x must be less than 2. So I hitting a Caribbean country soon. Well, you can see, I hitting another Caribbean country soon. And I will try to organize the books for that country as well. And then I'll hit another one. And it depends on how the book sales go. -1 is less than 2 if I can hit another one. What inequality is shown in the number line here? Well, I hope you all seen it's the arrow is pointing this way now. So it's -1 and 0 now. But we want the value to be less than -1. Who's saying less than? Let's see. X is less than -1. You all following me? And x is also more than 0. This is ideal. And this union here just stands for or. And some messages on the inside here. Which are the following sets is represented by the relationship f of x is equal to x squared plus 4. F of x is equal to x squared plus 4. Well, we had to check all of these. 0 squared plus 4 is 4. 1 squared plus 4 is 5. 2 squared is 4. 4 plus. I can't believe we get lucky with the first one. 3 squared is 9. 9 plus 4 is 13. Only we get lucky with the first one. They tell me to check over number 18. Maybe I make a mistake in number 18. Let me check it over. Oh, geez. Look what I have here. All right, this And when I come to select the answer, I select the wrong thing. My bad. That's strange. Yeah, so the arrow should point this way and stay pointing this way. Thanks by Simon boy. So x is greater than -1, right? And x is less than 2. So I have the when I explained it, it was correct. It's just that when I came to circling the answer, I just made a mistake. So I should have circled D, right? And I see some of you all said D earlier on. So if you're seeing it blurry, you need to change your resolution. We're coming down to the end here, ladies and gentlemen. If a quadratic is in the form, and all of these questions are from the question bank that these people in the comments talking about, and you can buy this in Nigel Arakan's book. So if a quadratic is written in the form that, then the axis of symmetry. So this is like the same ax plus h to b squared plus k. This time they just call it b and c. And the axis of symmetry is always x is equal to -h. X is equal to -h. So in this case, it's x is equal to -b. C. X is equal to -h. So like if it was 2x minus 3 to b squared plus 10, the axis of symmetry is x is equal to 3. Because I had to switch the sign and it's -3. So +3. Done. Nice. Well, CXC doesn't give you colors, but they could test this concept. Then we're going another time to print no paper and no color the ink. Purple car is 5 kilometers away and moves at an average velocity of 30 kilometers per hour. Blue car is 4,000 meters away and moves at an average velocity of 20 kilometers per hour. Green car is 6 kilometers away and moves at an average velocity of 72 kilometers per hour. However, it takes an additional 5 minutes before it's out. What kind of long, hard question is this, boy? Black car is 5 kilometers away and moves at an average velocity of 9 meters per second. Which of the cars will reach their destination first? Jeez, you see these kind of questions where you need to check everything? Them is question to waste your time in the exam, boy. All right, 5 kilometers away, 30 kilometers per hour. So this is going to reach in 5 divided by 30 divided by 5. How much time? So that's 6. 1/6 of an hour. Because, okay, speed is distance over time. How many of you all knew that? So time, we're going to see who will reach first now. We're in the shortest time. Time is distance over speed. So in this case, the time would be 5 over 30. So this is 1/6 of an hour. 1/6 of an hour converted to minutes is how much? 10 minutes? We know that often. So bro, you taking 10 minutes. Let me see if anybody can beat you. 4,000 kilometers away, 4,000 meters away, 20 kilometers per hour. Same thing, speed over time. Next one. Distance over speed. So it'll be 4 kilometers, because I'm changing it to kilometers because they ain't catching me with that. 4 kilometers over 20 kilometers per hour. This is 1/5. So this is 1/5 of an hour. 1/5 of an hour is how much? 12 minutes. So you done too slow already, bro. 12 minutes. Green car is 6 kilometers and moves 72 kilometers per hour. However, it takes an additional 5 minutes to start. How many times? So this is the same setup. I hope everybody following. You might have to pull back and watch it over a few times. This is distance over speed. 6 divided by 72. How much time 6 is going to 72, are there? Now 112 or some kind of thing, so 6 into 6, 1, 6 into 72, 12. So this is 1/12 of an hour, which is pretty good. That's 5 minutes. But it takes an additional 5 minutes to start. So 1/12 of an hour plus an additional 5 minutes. 1/12 of an hour is 5 minutes. 1/12 of an hour is 5 minutes. 12 into 60 minutes. 1/12 of an hour is 5 minutes. Double check that. Plus the 5 minutes. So this is back to the 10 minutes. So this is actually taking the same amount of time as the first car. So by elimination, it has to be this car. 5 kilometers away. Wait. It moves at an average velocity of 9 meters per second. Jeez, not meters per second, then what we convert here, boy. But by elimination, it has to be the black car because this one tie with this one and this one is slower. So had to be the black car. But okay, we had to change 9 meters per second to kilometers per hour. Or instead of going through that piece of working, which could be a little more programmatic, we could change this one to meters 5,000 divided by 5,000. 9 over 5,000. How fast that car moving, boy? Now we still need this will give me the time in seconds. It might be better to change this to kilometers per hour. To change to kilometers per hour, you multiply 9 meters per second, 9, you divide by 1,000, and you multiply seconds, hour, you multiply by 3,600. And you know that conversion making sense, so let's double check and see if that making sense. 9 meters per second, if you want to go to kilometers per second, we'll have to divide by 1,000. And if you want to go to kilometers per hour, 60 seconds in a minute and 60 minutes in an hour, 60 by 60 is 3,600. So yeah, this works to me. This looking like it working to me. Multiply by this 0.9 times 36. This is not pretty. This is not pretty at all. 9 by 36, 36 by 9. This question is our time waster, boy. Jeez and ages. 4, 5, 27, 33, 24. So this is like real fast. This car is moving real fast for no reason at all. So yeah, black car. Black car take the cake, boy. 32, 3.2. Black car take the cake. Black car moving fast. 32.4. I thought it was real fast, but just a little faster than this guy. 32.4 also. A student leaves home at 9 a.m., arrives to school 75 minutes later, and leaves school at 2:25. How long was he in school that day? 75 minutes later means that's an hour and 15 minutes. That is an hour and 15 minutes. So some of you all need to go back and watch the working I did on the last question, and based on what I'm seeing in the comments. It's recorded, it'll be up on the channel, you can always watch it over. So this would be an hour and 15 minutes because it's like 60 plus 15, right? So this actual time that he arrived at school will actually be 10:15. You all understand? Because he left at 9 o'clock. So we really want to find out how much time from 10:15 to 2:25. And in my mind, I can do this and say 10, 11, 12, and at least 13. 1, 2. Right now we're on 2:15, and that's 1, 2, 3, 4 hours. And to go from 15 to 25 is 10 minutes. So 4 hours, 10 minutes. A lot of you all got that really quickly. Which on the graph below represents an object at rest. Answer this one, class. Which of the following graphs represents an object at rest? Is it this one? Well, this is a distance time graph. Watch the units, meters, second. So it's increasing its distance. So this is not at rest. This is a constant velocity. Constant velocity. Is this at rest? Is this guy at rest? Well, this is constant velocity as well, now. You know why this one is still constant velocity? Because the unit change here, boy. The unit change. This is velocity now. This unit here is distance. So this is not at rest. If something is moving at a constant speed, it's not at rest. This is not at rest as well. Is this one at rest? It's the same distance as the increase. This is at rest. He resting. Resting, bro. So this one is good. How about this one? Well, this is still velocity and time, but however, the velocity is 0. So this means it is at rest. Even though it's constant velocity, it's constant 0 velocity. So 2 and 4 is the best answer here. B is the way to go. Lessons. Last 3 questions, I think. Peter drove 80 kilometers in 2.5 hours. What was his average speed during the journey in kilometers per hour? Peter drove 80 kilometers in 2.5 hours. 80 kilometers in 2.5 hours. Somehow that question is sticking in, but whatever, let me just do it. Speed is distance over time. A clue to figure this out, distance over time. Let me make sure the same units. So you want 80 divided by 2.5. How much times 2 could go into 80? Now like 40, so a little more than 2.5, 32 times, right? 3, yeah, 5, 2, 10, 3, 2. What? 2.5, this sounds 32, B, yeah, B. Yes. No, I'm a multiplication hotting up my head right now. All you want to know the kind of multiplication I just wanted to get this to work. Because like it wasn't feeling so just now. But I change this to 25, I multiply this by 100, and then divide by 4 kind of thing just now, yes. Which of the following represents, and then bring back a point, which of the following equation represents a linear function? You can't be linear, you look in linear. You can't be linear. So linear, it must not have any powers and them kind of thing. It must not have y is equal to x squared or y is equal to the square root of x and no. It must just be no powers. No set of powers and thing. Even if you've seen stuff like sometimes it has some weird ones. But I'm trying to remember the weird one. This would still be linear if you see like y over x is equal to 2. Like if you see y over x plus y or something like that, yeah, this starting to. No, this could still be linear. It depends. But what does the dead giveaways? Anytime you've seen weird indices, that will create weird graphs. So this one is linear. So the values of x at the point where y is equal to 9x minus x squared intersect y equals 0. I'm trying to see in this here, man. Where it intersects y equals 0 is what? Y equals 0 is the x-axis. So when y is equal to 0, 0 is equal to 9x minus x squared. This will factorize in terms of x and 9 minus x. This is not a difference of 2 squares here. This is factorizing normal and humble. Yeah, I know the difference of 2 squares. So it's either x is equal to 0 or 9 minus x is equal to 0. So negative x is equal to negative 9, x is equal to 9. So it's 9 and 0. What are you for? 9 and 0, B. Just like that, we finish all the major style of questions that come in the exam in terms of relations and functions. On Tuesday, I will be taking a look at the next topic in the question bank, which is geometry and trigonometry. How much more days till maths? How much more days till maths? And the next topic will be vectors and matrices. Hopefully, I get that through next week and be able to do some sample papers as well. How many more days till maths, boy? Maths was supposed to already pass, but it's shifted back 3 weeks. So you must see about that 2 weeks and a little change. 2 weeks and a little change. So y'all can take a little rewatch, press like on the stream, share it up on Instagram, tag me. Once I see it later, I'll try to repost it. We'll be back at it Thursday. I'm going a little earlier these days, so maybe like around 4 o'clock on Tuesday, you can look out for the next stream. Until then, there's lots of important stuff for you to watch on the channel. Love and blessings.